Can sound insulation be improved by cutting a slit in a concrete floor construction? I got this question the other day and I talked about it, maybe it was even yesterday's video, where if you have this problem in a dwelling, let's say you have sound coming from your neighbors, and then you have the unit separation wall here. It's like apartment 1 and apartment 2. That's a better 2, I think. Apartment 1 and apartment 2. Let's say you have a good wall here. It's a really nice sound insulation wall. So our problem in this case would be the transmission path here. We're coming through the plate. So let's say that this is the ground floor. So this is the foundation, and maybe you have like a really thin one, 100 millimeters. And if this is a dwelling, you're gonna get some problems with the flanking transmission through the floor construction. Now, if we would zoom in here and look at it separately, let's say it would look something like this with the concrete floor, and then you have your unit separation wall up here. Now what if you could make a little slit here? We make a little incision, a little cut into the concrete. Not all the way, but a little bit down here. Some millimeters. Or now, maybe if there's some structural engineers out there, maybe you think I'm crazy. Well, we're just talking acoustics here, so let's only consider that for now and see what happens if this is a solution. If we had like our 100 millimeter foundation here, I'm saying you should probably not do this without some additional research to see whether it's okay, because it might be possible that you mess up the building frame and things go really bad if you start cutting in the concrete. So don't do that. This is just a theoretical explanation of what's going to happen with regards to the sound insulation. So let's say we make this incision down here, a little slit, but it's still connected. Will this reduce the sound transmission? The intuitive thing here is to think that, yeah, well, we have reduced the area here, so it should be less. But let me show you here what happens. This is a really great tool to demonstrate this. It's one of these little, let's see if the autofocus can catch it. It's a little, happy birthday machine. It doesn't make any sound like this. But when you give this one a little bit of support, let's go to this table of mine here, and you'll see what happens. I'm just gonna touch it on the edge of this table. You see, when we get a structural contact here, we get a lot of sound. And this is what happens. So even if we just touch this one a little bit on the edge, it's a little bit lower, yeah, it is. But the real improvement doesn't come until I separate it completely. I guess you could probably do an analogy with electricity once again. I mean, if you have two poles with 220 connected to a wall outlet. Now, if you touch them like this, it's gonna be bad for your health. So what if you just touch them a little? It's still gonna be bad for your health. The only way to be safe from the hazardous electricity is to not touch them at all. And this is a bit similar with sound. So this is also especially important with lightweight constructions also, where like you see the table here is actually quite an excellent loudspeaker. And if you have rotating machines or equipment and stuff like that, and you connect them to a lightweight construction, there's a risk that you get a very effective sound radiating device that can create some annoyance problems. So be very, very careful with that. It's that we acousticians, we would preferably like things to be, either it should be completely solid and unmovable, because things that cannot move are also very bad at producing sound. If it's going to produce sound, if you got a loudspeaker and the loudspeaker cannot move back and forth and push air, it's not going to create any sound either. So either it should be totally stiff or completely separate. If there's something in between, you end up in the compromise zone, and that's where problems gonna end up. And that's also reality, because you cannot construct a building that doesn't stick together somehow. But we need to find the optimal compromise, and there's no one-size-fits-all solution. There's probably an optimal solution for every project, because every project is unique, and especially with timber constructions, which is my specialty, that I've really devoted my whole life and career to, solving these problems in the wooden constructions. Yeah, so I think that's it for today regarding the acoustics. And in today's video, I'm wearing a brown leather wristband on my watch. So I thought we're getting close to springtime now, and it's getting nicer outdoors. So I thought, let's get some light brown leather. I also have a little splash of brown here on my pocket square and the dots. And I match it with this belt, which is also, it's not exactly the same, but it's close enough. It's difficult to find exact matches, especially with brown leather. However, when I've got this watch, I noticed that, wait a minute, this one is still in the daylight savings, the summertime. So it's 1 hour wrong on this one. And that means I haven't used this one for quite a long time, because we've been in the winter season with the darkness. And apparently I don't like these. I don't prefer these light brown leathers in the winter season. I tend to gravitate towards darker colors, because I get a huge amount of inspiration from nature and what goes out when I look out my window, and I just try to replicate it, and I just didn't feel this color. But today it felt natural, and it's also quite funny that we're closing in on the new date when you're gonna change this one back. So I didn't really bother. It's still running in the last year's daylight saving time, so it's just a couple of days and we're gonna set the clock again. So maybe I just leave it for now. And yeah, that's it. Thanks a lot. See you later.